Hi everyone, the problem I'm gonna discuss in this video is given an array of positive integers, we have to calculate the number of subarrays having product less than a given number k. Let's look at an example. We have an array A containing 1, 2, 3 and 4 and k is 10. The number of subarrays in the given array which have product less than 10 are as follows. Let's see how we can solve it in linear time. For linear time, we will use sliding window technique where we will use two pointers start and end to represent the window. Initially, both will point to index 0. So in the given array, start and end, which I represent it by S and E, both are pointing to index 0 and variable p will hold the product of that window. So p for this case will be just 1. Now we will keep incrementing end as long as p is less than k, which will also change the window along with it. But how will we know the number of subarrays contributing to the answer from each window? Let's see how. When S and E are pointing to index 0, we have only one subarray containing just 1, whose product is less than k. So let's put that count in some variable, let's say subcount. So subcount will hold 1 and the subarray contributing to this count will be just 1. Next we will increment the end to point to index 1. New product P will be 2, which is still less than k. So this time subarrays satisfying the condition are: one will be subarray only containing element 1, next one is the subarray only containing 2, and last one is the subarray with elements 1 and 2. So the subcount for this case will become 3 and the subarrays contributing to this count will be 1, 2 and 1 and 2. Now we will increment end to point to index 2. The new product P will become 6, which is 1 into 2 into 3, which is still less than k. So the subarrays satisfying the given condition, which is the subarrays where p is less than k, will be subarray containing only 1, subarray containing only 2, subarray containing only 3, subarray containing elements 1 and 2, subarray containing elements 2 and 3, and subarray containing elements 1, 2 and 3, which is the whole window. So the subcount will now become 6 and the subarrays contributing to this subcounts are 1, 2, 1, 2, 3, 2, 3 and 1, 2, 3. As of now, we have calculated the results for each window manually, but we can observe something from this which will make our job easier, which is that after every iteration of it, the answer is getting incremented by the length of the window, which means for the first case, when S and E were pointing to index 0, the answer was 1, which is the length of the window itself. For second iteration, window size got increased by 2 and the same number of subarrays contributed to the final result. That is why the answer became 3. For third iteration also, the window size is 3 and 3 new subarrays have contributed to the result. So we just need to keep adding window size, which is end minus start plus 1, to the result whenever a window satisfies the condition, that is p less than k. If p becomes greater than or equal to k, then we move the start towards right and update p accordingly. That is, we need to divide p with element at start pointer and increment start. So this was the gist of the solution. Next, let's look at the code. Here is the code at left side. I have initialized S and E as 0, which represent the window, result to 0 and p to 1. In this for loop, E will increment till the end of the array. We will find p like this whenever E increments. This while condition is for the case when p is greater than or equal to k, where we update p and increment start. This is the case when p is less than k, where we just need to note the current window's length and add it to result. When for loop finishes, we will just return the result. Next, let's dry run this code on the given example. So S and E are pointing to index 0. Now for loop will start. P will be just 1. It will not fall under this while condition as p is less than k. So this if condition will execute. Length will become end minus start, which is 0, plus 1, which is 1. And result will be result plus length. So result will become 0 plus length, which is 1. Now the E will get incremented to index 1. Now p will become 2, which is still less than k. So length will become end minus start, which is 1 plus 1, which is 2. So result will become now 3. Now end will again move to index 2. So p will become 3 into 2, 6. And length will become 3, which is end minus start, which is 2 minus 0, 2 plus 1, which is 3. And result will become 6. Now end will again increment. Now p will become 6 into 4, 24. So now this while condition will execute as p is greater than k. So now p will become 24 divided by the start element, which is 1, which remains 24, and will increment start. Now again it will remain in this while loop as p is still greater than k. Now p will become 24 divided by a of start, which is 2, which will become 12. Now again p is greater than k. Again this will remain in the same while condition. So this time, before this, the start will also get increment towards index 2. Now p will become 12 divided by a of s, which is 3. This will become 4, and start will also increment and it will go to index 3. So now it will come out of the loop as p is 4, which is less than k. So it will move to this if condition. Now length will become start minus end, which is 4 minus 4 0 plus 1, which is 1, and result will become 6 plus 1 7. So when it will go to the for loop, as end has already been reached, so it will come out of the for loop and it will return the result, which is 7. So this is how we'll get our required result, which is 7. Thank you.